Today we are going to learn chapter 13, lesson 1, sequence and their notations. So first, let's see what is a sequence. The definition of a sequence is an ordered list of numbers. So any ordered list of numbers, we call it a sequence. For example, the first line 1, 2, 3, 4, 5. This is an ordered list of numbers. We call it a sequence. And the second line, it is also an ordered list of numbers. We also call it a sequence. So the sequence needs to have two prerequisites. The first one is it is a list of numbers. It might be infinite. It also might be finite. Another prerequisite is it is an ordered list of numbers. The keyword is ordered. For example, the first one, 1, 2, 3, 4, 5. What is the order in it? The order in it is the difference of two adjacent numbers is always 1. For example, the first one, the second one, 1 and 2, the difference is 1. And the second one and the third one also is 1. So the difference is always the same. So that is what we call ordered list of numbers. And the second one, 2, 4, 8, 6, 13, that's 32. That is still a sequence because there is an order in it. And the common difference is 2. Any difference of two adjacent numbers is 2. So now we know what is a sequence. We need to also know some other concepts. The first one is a term. What is a term? After we know what is sequence, we need to know what is the term. Each number in the sequence is called a term. For example, this sequence, 2, 4, 8, 16, 32, and continue. This is obviously is an infinite sequence. And we call 2 the first term. We call 4 the second term. We call 8 the third term. We call 16 the fourth term. We call 32 the fifth term. Continue. Listing all the terms for a sequence can be cumbersome. That is our problem. We know a sequence is an ordered list of numbers, but many times the list of numbers, they are infinite. So how to describe a sequence? How to describe it? So we need to find a way to describe a sequence. So one way to describe a sequence is to give a formula to the sequence. So now we need to go to two different ways to define a sequence. The first one, we call it explicit formula. For example, this sequence, 2, 4, 8, 16, 22, and continue. And we can't write it infinitely because it is too cumbersome for us. So we need to find a way to describe this sequence and in an easy way. Now we need to find the regularity in it or the order in it. After we observe the sequence, we found 2 equals 1 to the power of 1, 4 to the power of 2, 8 is 2 to the power of 3, 16 is 2 to the power of 4, and 22, this is not 22, this is 32. They make mistakes. And 2 to the 5th is 32. So now we can see, or we can define the sequence as A sub n equals 2 to the power of n. So A sub n, A is a lowercase. And the sub n, this n means the position of the term in the sequence. For example, the third one. The third term of the sequence is 8, then n equals 3. So the first term, the second term, the third term, the fourth term, the fifth term. So n means the position of the sequence, of the term in the sequence. And the an represents the nth term of the sequence and equals 2 to the power of n. Now we know the formula of the sequence is an equals 2 to the n. Then we can find any term in that sequence. For example, we want to know the sixth term. So the sixth term is a6 equals 2 to the power of 6 equals 2 to the fifth is 32. 2 to the sixth, we just need to times another 2, which is 64. So now we see the advantage of an explicit formula. As long as we have explicit formula, we can find any term of a sequence, as long as we know the explicit formula. So next. We go to see another way to find or to define the sequence. Okay, another way to define a sequence is we call it a recursive formula. So the first one is explicit formula, and the pattern is an equals what? And what is the regularity or the rule of the sequence? And another formula, we call it a recursive formula. What is a recursive formula? For example, this one. This one is a typical recursive formula. So we don't know an. For example, I ask you to find the a3. We don't know how to find a3. We just know an equals 2 times an minus 1 minus 1. We just know the relationship between two adjacent terms in the sequence, but we don't know exactly the term, the nth term of the sequence. For example, I ask you to find the value of a sub 3 or the nth or the third term of the sequence. We don't know. We just know a3 equals 2 times a2 minus 1. We just know the relationship between the second term of sequence and the third term sequence. So how to find the nth term of the sequence? By using a recursive formula. For example, this one. Normally, a recursive formula, they will give you the first term like this. So a1, we know is 3. So how to find a3? We know a1 equals 3. Then we can find the next one. We need to find one by one. So the term that is adjacent to a1 is a2. So a2 equals, according to the recursive formula, a2 equals 2 times a1 minus 1. And as we know, a1 equals 3. So 2 times 3 minus 1 is what is 5. So now we know a2. Then we can find a3. a3 equals what? a3 equals a1n equals 3. a3 equals 2 times a sub 3 minus 1, which is a2 minus 1. Now we know a2 is 5. So 2 times 5 minus 1 is 9. So now we can find the a3. So if we compare the recursive formula with the explicit formula, their difference is very obvious. The explicit formula, we can find any term of the sequence directly from the explicit formula. But a recursive formula, we can't find it. We need to find A2, A3, N2, the one you need. But a recursive formula defines the relationship between two adjacent terms. So that is a recursive formula's advantage. Okay, let's go back. Let's go back the definition of recursive formula. Recursive formula is a formula that defines each term of a sequence using preceding terms. That's the definition of recursive formula. Okay, let's go back to the explicit formula. So now we know there are two ways to define a sequence. One is explicit formula, another one is recursive formula. And we know what is the definition of term, what is the term, how to find the nth term by using explicit formula. Also, we know how to find the nth term by using recursive formula. Now, I think we should try some examples. Before we try some examples, I want to introduce a concept to you. One is the infinite sequence. In fact, I already mentioned that. A sequence that continues indefinitely is called an infinite sequence. So especially for infinite sequence, we must use a formula to define it, or we can't do it from the first term until the nth term. And another type of sequence, we call it a finite sequence. If a sequence is called a finite sequence, that means it does not continue indefinitely. For example, this sequence 2, 4, 8, 16, 32 until 1024. So it has an end for a finite sequence. The definition of an explicit formula is here. An explicit formula defines the nth term of a sequence using the position of the term. Don't forget the position, how to use the position of the term. The position means n, and the n represents the position of the term. 1n equals 3, that means the position of this term in the sequence is the third one. Okay, let's see one example. Writing the terms of a sequence defined by an explicit formula. Let's try to use the explicit formula. So the question, write the first 5 terms of the sequence defined by the explicit formula an equals -3n plus 8. So this is a quite easy explicit formula. So now the first term n defines the position of the term in the sequence. So 1n equals 1, which means a1 is the first term of the sequence. So a1 equals -3 times 1 plus 8 is 5. When n equals 2 means we will have the second term of the sequence equals -3 times 2 plus 8 equals 2. So continue, we can have a3, a4, and a5. It's very easy. So next question. Try 8. Write the first 5 terms of sequence defined by the explicit formula. So still using the similar way, when n equals 1, we get a1. a1 equals 5 times n equals 1 minus 4 is 1. When n equals 2, A2 equals 2 times 2 minus 4 equals 10 minus 4 is 6. So n equals 3. A3 equals 5 times 3 minus 4 is 15 minus 4 is 11. And n equals 4. A4 equals 5 times 4 minus 4 is 20 minus 4 is 16. And n equals 5. A5 equals 5 times 5 minus 4 is 25 minus 4 is 21. So the first 5 terms is 1, 6, 11, 16, and 21. Continue. Investigating alternating sequences. After I introduced the infinite sequence and the finite sequence to you, the next one I want to introduce is alternating sequences. It is also very easy. So sometimes sequences have terms that are alternate. In fact, the terms may actually alternate in sign. For example, this term. 2, -4, 6, and 8. If compare with this term, 2, 4, 6, 8. So this this term is quite easy. And the first one is 2. And the second one we can write as 2 times 2. The third one we can write 2 times 3. The fourth one we can write 2 times 4. So it is very easy for us to find the explicit formula for this sequence. So how to do it? An equals 2 times n. So 1 equals 1 is 2. N equals 2 is 4. Equals 3 is 6. Equals 8 is equals 4 is 8. But this sequence is different. It alternates sign. The first element positive, the next one is negative. Then the third one is positive. The fourth one is negative again. So how to define this kind of sequence? So it's still easy. We find 1n equals, or n is odd. For example, 1 and 6. This is the first one, this is the third one. So 1 is odd, it is positive. 1n is even, it is negative. So how to do it? We can use a technique to do it. For example, we can use -1 to the n, to the 2n to define this one. Then times 2n. Now we can tell 1n equals 1, an equals -1 to the power of 2 times 1, which is 2 times 2n. So 2 times 1. So it's a positive 2. So by using -1 to the power of 2n, we can make the term alternator in sign. Okay, that is a tip or technique. So example 2, writing the terms of an alternating sequence defined by an explicit formula. So if a sequence is alternate, it must have something like this, like -1 to the power of n, or -1 to the power of 2n, or -1 to the power of 2n plus 1, something like this. So now we try to find the first 5 terms of this alternating sequence. So try 1n equals 1, -1 to the power of 1 times 1 to the squared. And the numerator, the denominator is 1 plus 1 equals -1/2. And n equals 2, still plug in n equals 2, and we get 4/3. So it's a negative, positive, negative, positive, and negative. Okay, it's very easy to find the nth term of an alternating sequence. So this example, we can skip it. Okay, next concept, piecewise explicit formulas. So for piecewise explicit formula, always see piecewise sequence. It's not that common, yes, but we still need to know it. So piecewise explicit formula, for example, example 3. Writing the terms of a sequence defined by a piecewise explicit formula. Let's observe the piecewise explicit formula. An equals 1n is not divisible by 3, it is n squared. But 1n is divisible by 3, it is equal to n divided by 3. So we can try. 1n equals 1. And 1 is not divisible by 3. So a1 should be equal to 1 squared. We should use the first one. So 1 squared is 1. 1n equals 2. 2 is still not divisible. So still use the first explicit formula. So a2 equals 2 squared equals 4. But 1n equals 3, it is divisible. Then we use third one. 3 divided by 3 is 1. So it's pretty easy. Then by using the similar process, the similar technique, we get A4, A5, and A6. Okay, next one. Example 4, writing an explicit formula for the nth term of a sequence. Question, example A. -2/11, 3/13, 4/15, 5/17, and 6/19, and it continues. So this is an infinite sequence. To write an explicit formula for a sequence, a very important thing of the first step is to find the rule or the order or the regularity of the sequence. For example, the A sequence, what is the rule? The rule is the numerator to the difference of two adjacent numerator is 1. And what is the rule of denominator? The rule of denominator is the difference of two any adjacent numerator is 2. So 2, 2, 2. So how to do it? At this moment, the first term is very important. The first term is 2/11. Now we can temporarily ignore the sign. It is also an alternating sequence. So first we ignore the sign. So the sequence is 2/11, 3/13, 4/15, and 5/17, and 6/19. So this is n equals 1, this is n equals 2, this is n equals 3, and this is n equals 4, this is n equals 5. After we find the regularity of the sequence, we need to model the explicit formula. Another important thing is we need to find the relationship between n or the position and the regularity. So when n equals 1, it is 2/11 when n equals 1. So a1 equals 2/11, a2/3/13. So how to write an? So one, can I write for 2 and 3? The numerator, the difference is only 1. So can I see the numerator is as 2 plus n? So when n equals 1, it is 2 plus 1 is 3. So it becomes 2. So how to do it? So how about we write this? So 2 plus n minus 1. When n equals 1, 1 minus 1 is 0, then it's 2. When n equals 2, when n equals 2, 2 minus 1 is 1. 2 minus 1 is 3. So we figure out how to do it. And the second, or the next thing, is numerator. The first numerator is 11. By using the similar technique, how to do it? And still minus 1. But the difference is 2, so we need times 2 in front of it. So 1n equals 1. So 1 minus 1 is 0. 0 times 2 is 0. So a1 still is 2 over 11. But 1n equals 2. 2 minus 1 is 1. But 1 times 2 is 2. So 11 plus 2 is 13. So that is the typical process when we try to find an explicit formula. So now let's simplify it. The numerator becomes n plus 1. The denominator becomes 2n. 11 minus 2 is 9. Plus 9. So that is the explicit formula. But we still have the last step need to do. So the last step is, don't forget, it is alternating sequence. I said it's very easy. We just need to use -1 to the power of n, or 2n, or 2n plus 1, or 2n minus 1. Let's try which one works. So when n is odd, it is negative. So how to do it? So -1 to the n. By using negative to the power of n, we can define the sign. When n equals 1 is negative. When n equals 2 is positive. So when n is even, it is positive. When even n is odd, it's negative. So now we find a way to do it. So an should be equal to -1 to the power of n times n plus 1 divided by 2n plus 9. It's not easy, but we can do it. Next, sequence B looks like more difficult. So 25, 125, 625. From the first 3 denominators, we find the regularity. 25 is 5 to the power of 2. 125 is 5 to the power of 3. 625 is 5 to the power of 4. So next one is 5 to the 5th. Next one is 5 to the 6th, and continue. So now we find the regularity of the denominator, and the regularity of the numerator is very easy, always 2. So for sequence B, an equals, and each term is negative. So we just need to write the negative sign in front of the expression, and the denominator is 2. Denominator is 2 to the power of n. We try this part we need to try. When n equals 1, it is 5. But the first term, n already is 2. So don't forget another important step is we need to find the relationship between the position and the rules. So the position, the first one, position is 1. This is 2. This is 3. This is 4. This is 5. Now let's try to find the relationship between the position and the rule. So when the position is 1, the exponent is 2. When position is 2, the exponent is 3. When position is 3, the exponent is 4. So what's the relationship? The relationship is n plus 1. So this is 5 to the power of n plus 1. So this is the explicit formula for sequence B. Okay, the third one, C, 1n equals 1, a1 e to the fourth. The second is 5. The third is 6. The fourth is 7. Is 8. So still the first step, find the rule of regularity. The rule is the exponent, the difference is always 1. So the second step is to find the relationship between the rule and the position. Always say the rule and n. There must be some relationship. So when n equals 1, e is 4. So can I see e to the n plus 3? The second one, 2, 5, still n plus 3. So the third one, 3, 6, still n plus 3. So how to define the third sequence? an equals e to the power of n plus 3. Okay. We already know what is the recursive formula. Let's try some examples of recursive formula, talking about recursive formula. So example 5, writing the terms of a sequence defined by a recursive formula. So write the first 5 terms of the sequence defined by the recursive formula. So I said for a recursive formula, normally they will give you the first term and then give you the recursive formula that defines the relationship between 2 adjacent terms. Okay, a1 we already know is 1, so 1n equals 2, a2 equals 3, a1 minus 20. a1 is 9, so 3 times 9 minus 20 is this 27 minus 20 is 7. So a2 is 7. So a3, now we know a2, how to find a3. a3 is according to the recursive formula equals 3 times 2, a2 minus 20. So 3 times 7 minus 20 equals 21 minus 20 is 1. And continue, we have a4 and a5. So we try one. a1 equals 2. So how to find the a2? a2 equals 2 times a1 plus 1. a1 is 2. 2 times 2 is 4. 4 times 1, 4 plus 1 is 5. So a3 equals 2 times a2 plus 1. So 2 times 5 is 10. 10 plus 1 is 11. Continue, a4 equals 2 times a3 plus 1. 3 is 11. So 2 times 11 is 22 plus 1 is 23. And a5 is 2 times a4 plus 1. a4 is 23. 2 times 23 is 46 plus 1 is 47. So that is the first 5 terms of the sequence. The last concept I want to introduce in lesson 1, chapter 13, is using factorial notation. In fact, is to know the concept of factorial. And what is factorial? Let's see the definition. The formulas for some sequences include products of consecutive positive integers called factorial, and n factorial, written as n factorial, is the product of the positive integers from 1 to n. For example, 4 factorial. So 4 factorial, you need to find the product from 4 and the from 4 and the consecutive positive integer. The consecutive positive is 3, then is 2, and then is 1 is 24. So 5 is from 5 times the consecutive positive integer 4 times the consecutive positive integer 3 times the consecutive positive integer 2 and times the consecutive positive integer 120. So how to define n factorial? This we call it 4 factorial. This is we call it 5 factorial. So how to define n factorial? Still very easy. N factorial is we need to find the product from n and the adjacent or consecutive positive integers n minus 1, n minus 2, continue to 1. Okay. So let's see the factorial definition. N factorial is a mathematical operation that can be defined using a recursive formula. The factorial of n denoted n factorial is defined for a positive integer as we need to remember n 0 factorial equals 1. That is something we need to memorize and something defined. And the 1 factorial is 1, and n factorial is n times n minus 1, n to 1. Okay. The special case, 0 factorial is very important. 0 factorial is not equal to 0. It is equal to 1. Okay, try example 7. Writing the terms of a sequence using factorial. The question is writing the first 5 terms of sequence defined by the explicit formula a(n) equals 5n to the n plus 1 factorial. It's still very easy. When n equals 1, just plug in n equals 1 everywhere. So 5 times 1 and 1, this is 1 plus 2 factorial. So 5 over 3 factorial. 3 factorial equals 3 times 2 times 1 is 6. So 5 over 6. The second one, n equals 2, still the same. Plug in n equals 2 everywhere. So 2 times 5 times 2 over 2 plus 2 factorial is 10 over 4 factorial. So 10 divided by 4 times 3 times 2 times 1 is 5 over 12. Then continue, we can find the first 5 terms. So about the n factorial, I don't think we need to practice more. It is quite straightforward. So that is the end of lesson 1.